All right, welcome everyone to 7.2. We are finishing it. And I hope you guys have been enjoying the leisurely pace of this class so far, because we are finishing, well, really the first 2 weeks are kind of weird because of how things went. We've only covered a section a week, which is pretty slow. We're going to start picking up some speed soon, starting next week, all right? 7.3 we're going to go through pretty quickly. 7.4 we're going to go through pretty quickly. Chapter 8 in general, we're not going to necessarily cover everything. We're going to spend a big bulk of this class in chapter 9. So we were on example 6, so let's jump right to it. Example 6, and we were still talking about complementary angles and cofunction identities. All right, so let's go ahead and move this guy a little closer up here. All right, so if cosecant of pi over 6 equals 2, find secant of pi over 3. Okay, so we got to use what we know about cofunctions, complements, and stuff like that. So at the end of last time, we talked about, well, I was going to show you my old notes. These are my lecture notes. They're not very helpful. They don't have any information on them. But we said that if we had a complement, and by the way, pi over 6 and pi over 3 are complementary angles. Again, this is 30 degrees. This is 60 degrees. They add up to 90 degrees, or pi over 2 radians. These are complementary angles. So what that means is that the cofunction values of their complements are the same. So this is really an easy problem. The answer is staring you right in the face. The cosecant of pi over 6 is the secant of pi over 3. It's a trick. We already found it. It's right there. All right? And that's the whole point of cofunctions and other stuff. So again, another way of seeing this, if you wanted to, is you could draw a triangle. All right, so this is one of our special triangles, pi over 6 and pi over 3. Okay. Now, so, getting distracted. What we have, right, cosecant is 2. Remember, cosecant is just the inverse of sine. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. This is one such triangle that would have the cosecant of 2. All right? There are infinitely many triangles. Triangles can be any size. And we don't know what size this triangle is, only that the ratio of those sides is 2. Okay? And so the secant of pi over 3, well, secant is 1 over cosine. Cosine of pi over 3 is 1/2. Secant is the reciprocal, which is also 2. All right. So a couple of different ways of approaching these problems. You can think about it in terms of cofunctions and complements, or you can think about them drawing triangles and pictures. Very helpful to have multiple ways of approaching problems. All right, one more problem that I'm kind of sticking in here that I wasn't planning on talking about, but I want to do one more solve a triangle problem, because there can be some tricks, and some of the book problems are a little tricky, so I want to make sure I get that out there. We're going to have a nice tilted triangle here. I was playing League of Legends earlier today. There was a lot of tilted things in those games as well. And so let's say we have a 30-degree angle right here. Not 300s, that's 30 degrees. And the long side of the triangle is 7 units. So find B and C. And again, we know this is 60 degrees because all the angles in a triangle need to add up to 180 degrees. Okay? So let's go. How are we going to do this? And you might say, oh, I remember 30, 60, 90 triangles, Jason. You talked about 30, 60, 90 triangles. This is going to be 14, and this is going to be 7 square root of 3. But be careful, because the actual 30, 60, 90 triangle that we introduced had the short side being 1, the hypotenuse being 2, and the square root of 3 being the long side. But this is the long side already. We're used to the long side of 30, 60, 90 triangles having square roots of 3. But that doesn't mean they need to have them. The long side is always the square root of 3 times the short side. So conversely, the short side is the long side divided by the square root of 3. So b is actually 7 divided by the square root of 3. And again, you do not need to rationalize the denominator in this class. But if you wanted to, you could, and it would be 7 root 3 divided by 3. So be very careful here. Short side is 7 divided by root 3. So the long side is the short side times the square root of 3. And yes, if you multiply this by the square root of 3, they cancel and you get 7. So we know we did it right. And then the hypotenuse is always double the short side. The short side is this, so double that. It's going to be 14 divided by the square root of 3. So be very careful on some of these book problems. They're out to trick you. And in general, my teaching and testing philosophy is that I always want the homework to be the most difficult problems that you see. The quizzes will be the next difficult, and the exam problems shouldn't be as difficult. The goal is that the exam problems are just a test. Do you kind of understand this material? Whereas the homework is really drilling you hard and making sure that you truly grasp it. So you should know when you're doing a homework assignment whether you go, yep, I understand this. I'm getting all the right problems. I'm doing the odd problems sometimes. I'm checking my answers in the book. I'm checking my answers. And I understand this so that when the quiz comes around, you know what to expect. And then your quizzes give you weekly feedback, and then the exam comes around, and you shouldn't be surprised. Okay? So let's get into the applications. And again, I said today was going to be short. I said enjoy the last leisure while you have it. The applications, there's only 2 more problems we're doing today, and then we're going to be done. Next week, the video lectures are going to be a lot longer, just the way that class is panning out with holidays and stuff. So let's get into some applications. The most important thing, I'm going to say this a lot, the most important thing when you're doing an application is to get a good picture. Sometimes the problem will give you a picture. Sometimes the problem will not give you a picture. If you don't have one, draw a picture. In everything for this class, if you can draw a picture, first off, partial credit. Second off, it can help you get prepared. So before we do this, we got some definitions for everyone. Say you're a stick figure. I apologize for you losing your third dimension. Say you're a stick figure and you're really happy, kind of it looks like a one-eyed, all right, cyclops stick figure. And you're looking at something. You're looking at the top of a building or something. The angle that your eyes make with the top of the building and the horizontal, this is called the angle of elevation. So that's a good definition. Likewise, if you're standing off right at the edge of the cliff and say you're looking at like a little bunny with a nice fluffy tail. That's not, all right, don't worry about that. Say you're standing and you're looking at the bunny. The angle that your eyes make with the horizontal, this downward angle, is called the angle of depression. Okay? So if anyone remembers anything about high school geometry, the angle of elevation and the angle of depression are actually the same thing. All right, if you have 2 parallel lines cut by a transversal, this downward angle, angle of depression, is the same as the upward angle, angle of elevation. So they're both the same. We can use that later. So let's get into some application problems and use this information. We're on example 8. We got 2 application problems. Again, short video today. We got a person, and what they're doing is they're walking 10 meters from the base of a tree. And they measure an angle of elevation and be very clear here, from the ground to the treetop of 57 degrees. And the question is, find its height. So we're not given a picture. If we're not given a picture, We got to make a picture. All right. So this is unfortunate timing on the page. We are running out of page, but this is okay. So we got a person. We're going to leave the person out because they're measuring from the ground anyway. So actually what we could do, let's say the person is on the ground. Okay. Wait a minute. Oh, crap. I drew their head upside down. It doesn't matter. And then we got a nice little tree. And the angle from the ground to the top of the tree is 57 degrees. Okay. And the question is, if they walked 10 meters from the tree, so this distance down here is 10 meters, what is the height? So that's like the high quality artistic picture. But some of you may just prefer to draw a triangle, right? This is 10 meters. This angle is 57 degrees, and we're trying to find x. So a lot of times it can be helpful to draw two pictures. One with all of the stuff in it, so you really know like what thing is what. And then once you draw this, a lot of times it can be helpful just to strip away all this beauty and just have the facts. Okay, so that's our triangle here. So we haven't really done problems like this yet, but we've got some information. It'd be really nice if we could relate this angle with this side with this variable. If only we had some sort of function to do so. Is there a function that relates an angle to its opposite side and its adjacent side? Exactly, we got tangent right here. The tangent of 57 degrees is x over 10 meters. So that's what we do. The tangent of 57 degrees is x opposite divided by adjacent, which is 10 meters. And then we just need to find out what x is. So we solve this equation just like every other equation. So we multiply both sides by 10, and you're going to get x is equal to 10 times the tangent of 57 degrees. And I have a very, very important warning here. When you are using your calculator, you will be using it to find trig functions in degrees and in radians. It's imperative to always be checking whether your answer is in, or whether your calculator is in the correct mode. If you don't know how to do that, tell me what kind of calculator you have and send me an email, and I can give you some links to help you make sure that you have that correct. Also, your answer should make sense. We haven't solved the problem yet, but if we solve this problem and use radians instead of degrees, we might get an answer that makes no sense. So let's type this into our calculators. 10 times the tangent of 57 degrees. All right, and it is about 15.40 meters. Again, include units in your answers. If over here the tree is 10 meters away, that means the height is going to be 50 meters. All right, another way of kind of gut checking whether this answer makes sense is realizing that this is close to, but is not actually a 30, 60, 90 triangle, right? 57 is close to 60. This is a right angle here, which means this over here is going to be 33 degrees, which is close to 30. Okay, so this is the long side. It should be roughly the square root of 3 times 10. The square root of 3 times 10 is actually about 17, I believe. So, you know, ballpark estimate. If you use radians instead, I think you would have gotten like 4 or 5 meters, which is much too short for this specific tree. Okay. Anyway, here we go. That's it. One more example problem and we'll be done. Example 9. What happens when a kitten accidentally turns off a computer during a trigonometry lecture? And the answer is, if you take the sine of the kitten and the cosine of my fury, the kitten gets kicked out of the room. Okay, so anyway, that was a bonus problem. Extra credit on your exam if you pay attention. So, how long, how long of a ladder is needed, I'm looking at my notes, my grammar is terrible in my notes, is needed to reach a window that is 50 feet above ground. If the ladder makes an angle of 75 degrees, with the ground. Seems like a pretty decent angle for a ladder to be on. Then round to the nearest foot. Okay. So, what is the first step? I don't know. Let's bring that broken record over here. Yes, exactly. Draw a picture. Very good, broken record. So we've got a ladder, and we've got a nice window. Say this window is up here. There's some people maybe having a nice Christmas gathering here. We'll give them a door so they can leave when they want. And get a nice stereotypical roof. And then we got a ladder, and the ladder needs to reach the window. And so we prop up our ladder like this. Yeah, this is very good. Our angle is 75 degrees, and the window is 50 feet above ground. Wait, 50 feet? That's pretty high. I don't know what story that would be on. So that's the pretty picture. Again, maybe you could just spice it up a little bit. Have a nice little sun shining down and a nice little tree. But the important stuff is the triangle, right? What triangle do we have right here? We have a triangle with an angle of 75 degrees, a height of 50 feet, and what are we asked to find? Yes, all right, I found it. We're asked how long the ladder has to be so that it can reach. Because you can't just get a 50-foot ladder to get a window 50 feet. Okay? If you have a 50-foot ladder and you're going 50 feet, you got to place the ladder like right up against the wall. And that's a good way for the ladder to fall. And, well, we don't want to go there. 50 feet is a long distance. We'll do some gravity and acceleration problems later. See acceleration due to gravity, what your velocity. No, we're not going to. That's dark. We're not going to get that dark in trig class. Anyway, so really, all it is this triangle. Now, if only there was a trig function that related an angle to its opposite side and its hypotenuse exactly, just like it was said in chat, we're going to use the sine function. So the sine of 75 degrees is equal to the opposite side, which is 50, divided by the hypotenuse, which is x. And this is where actually a lot of people get caught up. If you need to brush up on your algebra skills, a problem like this can be very difficult. Whenever we have variables in the denominator, you have to be very careful. And the first step, when you have a variable in the denominator, there's a couple of ways around this, a couple of shortcuts. But in general, the best way to solve a problem when you have a variable in the denominator is to get it out. Okay? So we're actually just going to multiply both sides by x here. So we get x times the sine of 75 degrees equals 50. And now this is a much better equation to solve. All right, and we can just divide both sides by the sine of 75 degrees, which is good. So we're going to get x is 50 divided by 75. Because we're going to, sorry, sine of 75. 50 divided by the sine of 75. Oh, also a common error right here that you have to be very careful about is when we have 50 divided by the sine of 75, there's no cancellation that goes on here. Sine of 75 degrees is stuck within that sine. So there's no cancellation. This is as simplified as it gets. Okay? Be very careful. This is going to come back to bite you if you're not. So at this point, you do one thing, right? We're asked to round to the nearest foot. You take out your calculator. I don't have one with me. And you see, what mode is it in? Degrees or radians? You hit degrees. Make sure it's in degrees because we're dealing with degrees. And you punch that baby in. And what you're going to get is 50 divided by the sine of 75 degrees. That's approximately 52 feet. All right. And that's our answer. And let's say your calculator was in radians. Okay. This is the final answer. If your calculator was in radians, you'd get an answer of about negative 129 feet. And if you're talking about a negative 129 foot ladder and you give me that answer, I'm going to draw on canvas a big sad face. Don't give me this. Don't give me this garbage. Okay? No negative ladders here. Not in my trig class anyway. So a lot of times when you're dealing with applications, if you have the wrong units, it'll a lot of times be kind of obvious. Just think about your answer in context of the problem. 52-foot ladder to get 50 feet up, that seems a little short to me personally, but it's in the realm of possibility. So I trust that at least some of my math is probably pretty right. Okay. And that's basically it. Okay. Your first homework and quiz, your second homework, well, your first homework, your second quiz was due today. So if you had any trouble with that, please let me know. I've already gotten a couple emails of people figuring things out. That's the way this class is going to go every week. It's just going to go like that in the weekly modules. And again, I say this every video, but I really mean it. If you're ever confused about something or you want some clarification, don't hesitate to reach out to me, and send me an email. I'm usually pretty prompt with my email replies. Anyway, thanks for watching. I hope you have a great weekend and get started on the homework early. We now finished the section. You can start section 7.2. You can finish 7.2 and its quiz tonight if you wanted. All right. Anyway, thanks for watching. See ya.